All right, for these last two questions, we're trying to practice that factorial notation. So the first one is really just making sure that we, again, remember what that factorial notation means. So this one is asking us to do 5 factorial. So we're going to start with 5 and then keep working our way down until we get 1, multiplying as we go. So 5 times 4 times 3 times 2 times 1. And then you can do it in a calculator. That one maybe is small enough to just do in your head, but 5 times 4 times 3 times 2 times 1. Oops, not 55. Let's start over. 5 times 4 times 3 times 2 times 1 is 120. So we're just practicing these factorials. The second one I really want to draw our attention to. This one is going to teach us a technique for how to simplify things. This form that you see on the bottom where we've got some factorials on the top and some factorials in the denominator is a very common thing that we're going to start to see in our next section. So I want to show us some techniques for how to simplify it. So I'm going to do this 2 different times. I'm going to kind of do it a first time so that we can see how it works. And then I'm going to do it a second time that we do it a little bit faster. So let's take a look at this guy. So let's think about, well, what is 12 factorial? Well, 12 factorial would be 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. It's long, right? There's going to be all the way from 12 down to 1. And then on the bottom, I've got 5 factorial, which is 5 times 4 times 3 times 2 times 1 times 7 factorial. So times 7 times 6 times 5 times 4 times 3 times 2 times 1. Now here's what I want you to notice. Look at the numerator and the denominator and notice this whole thing appears in both places. We've got a 7 times 6 times 5 times 4 times 3 times 2 times 1. And when you're dealing with division, anything that's multiplied on the top and on the bottom can just entirely get canceled out. So then what we're left with is we're left with just 12 times 11 times 10 times 9 times 8. We would stop at 8 because the 7 got canceled and everything after it. And then in the bottom, 5 times 4 times 3 times 2 times 1. And then we would compute what those 2 different things are. So I typically just do them separate. So do the top first. So 12, 11, 10 times 9 times 8 is where we stop. So that one is 95,040. Let me just double check that I did it right. And then the bottom, 5 times 4 times 3 times 2 times 1. Well, we did that up above already, so I'm just going to write it down and not type it in the calculator again. And then we'll do the division last. So then we have that 9040, which I actually still have in the calculator. So then I'll just do divided by 120. So my final answer is 792. And then I want to write down a slightly different way to write this, because even that was a little tedious. Notice we knew that we were going to cancel a bunch of stuff, or we could know that we were going to cancel a bunch of stuff. So let me scroll down here just a smidge so that we can write this in a slightly different way. So write it in a faster way. And this will be especially helpful when we do examples later that maybe have larger numbers in them. So I'm going to rewrite the problem. 12 factorial over 5 factorial 7 factorial. So I'm going to start to write out 12 factorial. I'm going to write 12 times 10 times 9 times 8 times 7. And I'm going to notice, well, let's think about what's going to come next. It would be times 6 times 5 times 4 times 3 times 2. But notice in the bottom, I also have a 7 factorial. So what I'm going to do is rather than write out the rest of it, I'm just going to say times 7 factorial. Because that's what it is, right? That's what this whole thing that we canceled out is. So I'm going to just leave a 7 factorial in the top. And in the bottom, for now, I'm just going to leave it as 5 factorial, 7 factorial. I picked 7 because 7 was the bigger of the two. In theory, we could have canceled the 5 factorial, but then I would have had even more numbers to continue writing down. And then exactly what happened here is what we canceled on the top and the bottom, looking up above, really was 7 factorial. We canceled out 7 factorial with 7 factorial. Now I do write that exclamation point here because it's different than just having a 7, because 7 factorial is that whole string of multiplications. That's what we're canceling, is all of it. So then what we're left with is the 12 times, oops, I forgot my 11, excuse me. That would make a big difference. 12 times 11 times 10 times 9 times 8, all over 5 times 4 times 3 times 2 times 1. Which is the same thing that we had over there now. So when you multiplied the 12, 11, 10, 9, and 8, we got that 95,040. And when we multiplied the 5 times 4 times 3 times 2 times 1, we got 120. And then when we divided 95,040 by 120, we got 792. So this is my preference for how to write it, is to, once you hit the larger of the two on the bottom, just stop writing at that point and just put a factorial on it, and then cancel out that factorial from the top and from the bottom. And notice we only cancel numbers 1 with 1, right? Up here, like I had a 5 on the top. It canceled with this 5 on the bottom, not with this 5, not with the first one. You only cancel 1 with 1. So really what you're canceling is that whole factorial out. So you'll practice some of these, and then we're gonna use that we're gonna learn in the next section that we do why we would do something like this. But having practiced the math of it, the arithmetic part first, will help us then be able to do the question parts, the counting technique parts later without having to be also learning this new math technique on top of it. We'll just be practiced with this tool and able to use it in the future.